Okay, there was a request to rebuild this chart that we went over in class the last two sessions. So I'm going to copy this file from our class exercise, copy the tab by clicking on the tab, holding down the control key, and then letting it go. Before I let go of the control key, we've copied that tab. I'm going to copy this and paste it over here as an image. And we'll see if we can recreate something that looks a little bit like that. I'll get rid of the chart. I'm going to get rid of the calculations used to make that chart so we can go over them again. But I'm not going to recreate the returns or excess returns or covariance matrix. We can go ahead and rebuild this envelope. But before I do, I think I mentioned in class, sometimes it's handy to have a calculation space. So I'm going to grab this first row that's already got the formulas we want, and I'm going to paste it up here. And now I'm going to delete these with an Alt-HEA. And when we're using Solver, we're not going to have to point it at all these different rows each time. That's going to save us a lot of time and some potential for error. And so let's double check our formulas here. The way they are, we've got a sum formula, we've got the weight in Kellogg and ExxonMobil and Walmart, and then we've got a calculation for risk. So that is just this formula right here. And then we've got a calculation for expected return. And that's where we put in this formula. And so we've got everything we need here. As we optimize these portfolios, we can just paste them down here. In fact, to make it clear, I'm just going to paste the formulas, copy, paste. They don't mean anything yet, but when I put values down here like this, then it'll calculate a risk and a return for us. In fact, that one, we'll call it Kellogg. We know we want that at one end, and we want Walmart at the other end. So I'm going to copy that, put it here, and make it 0 and 100 for Walmart. Now we've got a point on both ends. Let's go ahead and put ExxonMobil for now in between. I'll make that 100%. And so we'll call that one Kellogg, we'll call this one XOM, and we'll call that one WMT. Now let's calculate some more points in between there. Let's do a minimum risk. So we'd come up here and do an Alt-A-Y3 to pull up Solver. And we want to set our objective, we want to set our risk to a minimum by changing these three cells such that this cell is equal to 1. Let's solve. And if I copy those three values, I've got a min risk. And I'm not going to optimize these because I'm trying to match this chart. So if I did a 80, 0, 20, let's see what that gets me. Should get me this point. And if I did a 39, 25, 35, I don't remember what we optimized on to get those. It doesn't matter. We're just trying to recreate this chart for the video. I don't know why I'm typing them in and copying them down here, but that's what I'm doing. And so this chart now should look a lot like that one. So let's make it. Let's highlight our risk and return and do an Alt-ND. Choose the one with no lines, or probably should have chosen the ones with a smooth line. But I can right click on it, format the data series, go to the bucket of paint, choose a line, get a solid line, and then smooth it. And that should look a lot like what we had. I have this weird inflection point up there, and let's talk about why. Let's put some data labels on these. So if I right click and add data labels, I don't want the values. I want to right click and format those data labels. I want to get that values from cells, and so it's asking me where to get the data label range. I want to get it right here. But I really don't need the Y values on there, so I'm going to get rid of the 12.8 and the 14.9 by turning off the Y value. And we've labeled the actual stocks themselves and the minimum risk. We haven't labeled these mixes that we made up. We've got a mixed portfolio here. Let's talk again about how to do those labels. We want to take that 80, which is really a 0.8, and we want to change it to an 80 using the text function. Take the 0.8 times 100, and then tell it how to format that. I want to format it with no decimal places, so I'm just going to put a 0 in parentheses. If I hit enter now, I get an 80 as text, which means I can use the ampersand and add more text to it like that. Hit enter. I could even add more text that looks like this. And more text that looks like this. And more text that looks like this. And so I have a label that I can copy and put down here. And notice now we have these labels that look a lot like what we had over here. I think the main difference between this chart and that one is we had a optimum risk portfolio on there. We had a tangent point, which we don't have. Now look at this weird inflection that we saw in class. That's because ExxonMobil is bringing this envelope down. It's not an efficient portfolio. We could get that same return for a lesser risk and not have an inflection point in our portfolio. So let's do that. Let's change this. Actually, let's come up here to where Solver is already looking. And let's see if we can achieve this return with a lower risk. So let's go Alt AY3. And we want to minimize the risk by changing the weights, sum to 1. And let's constrain it to say that our return is equal to this return. And solve it. And so we got our risk down to 20% instead of 26. So if I copy these three weights, paste them onto this line, it'll no longer be 100% ExxonMobil, but hopefully that point's going to move to the left. So when I hit paste, it did in fact move to the left. And so let's change the label because it's not ExxonMobil, it's actually a mix of stocks. Okay, so we've drawn our portfolio. If we had a tangent point on there and changed the scale of this chart, it would look a whole lot more like that chart. And one way we can change the scale of that chart is by putting on our capital allocation line, which we're going to calculate in these 6 cells. We're going to get 1, 2, 3 points for that. One thing we'll need to do though is get the tangent point, so we'll know where that optimum risk portfolio is. Let's just do that one up here and call it the tangent. The last time we need to use that line. And our Sharpe ratio is going to be the expected return minus the risk-free rate over, oops, that was supposed to be a risk-free rate, over the risk. And I want to copy that Sharpe ratio down to these others to make sure it is in fact the highest when we finish. So I'm going to lock this cell looking at the risk-free rate. Plenty of decimal places there, Excel, thank you. Okay, and we want to do an Alt AY3. Want to maximize the Sharpe ratio by changing these three weights such that they sum to 1. We don't care anything else about risk or return. That's all we need to do. We solve that. We get a Sharpe ratio of 72%. We have no clue what that means, but if we copy that formula and paste it down here, we see that nothing else is as high as 72. So we feel pretty good that this is going to give us a risk and return that gives us a slope as high as we could ask for with a 2% risk-free rate. So let's see if it does. The first point on that line is the risk-free asset, which of course has no risk. That's why we call it risk-free. And it has a risk-free, it has an expected return. This is the risk-free rate, of course. The optimal risk portfolio is the risk of the highest Sharpe ratio we could get and the return of the highest Sharpe ratio we could get. And then we want to extrapolate that out as far right as any of our stocks go. So let's take the maximum of any of these risks, which is of course going to be Walmart. And let's calculate the return that goes along with it. And so this was the formula we just used. This is going to be the return that goes along with it. Paste that in here and say take the risk-free rate. I need an equal sign to do that. Take the risk-free rate and add the Sharpe ratio times the risk extrapolated. And so this 1, 2, 3 pairs of risk and return should let us point this 1, 2, 3 points on the plot. So let's do that. Let's copy, choose the graph, do an Alt HVS, call it series, X values in the first column, they're in columns, no names, and say OK. You may notice that we're very close, but we don't actually have a tangent point up here. We're missing 1 point, so I'm going to take these, move them down, and create a tangent point. I'd like it to be between the minimum risk and the 39, 25, 30. So I really want it to be right here. Move that down. Copy this. And now we actually do have a tangent point. We're starting to look a lot like this other chart over here. In fact, the only thing we're missing is this gray dot, which is the portfolio risk and return. And this is after we mix in the risk-free asset with some stocks. Where does our portfolio risk and return end up? And that's just going to be a weighted average of the optimal risk portfolio here at that tangent point and the risk-free asset right here. So if we put 25% in the risk-free asset, then that leaves 1 minus that in stocks. So the risk of this point is going to be 0 risk times the amount going into risk-free plus the risk of the optimum portfolio times the amount going into that. Reason that out. Make sure you understand that. That's not on the formula sheet, but it's a very fundamental concept of what we're doing here to interpolate between these 2 points. Same thing on the return. This time we do have a return here that we can weight by the amount going into stocks plus the return of the optimum risk portfolio times the amount going into stocks. I think I said stocks there when I meant risk-free asset. Now if we've done this correctly, this point should end up on that line. So let's see, let's copy that, do an Alt HVS just like we did before. New series, columns, and sure enough we have a gray point that's on that line. So if I move this to put more into the risk-free asset, we should see that gray point move along this line. So if I went from 25 to 50%, I see that gray point move down. If I went up to 75%, it continues to move. If I went to 100%, it should be right on the y-axis. And if I went to 0%, it should be right on the optimum risk portfolio. I'll leave it at 25 where we started. Make sure you understand this point, how we calculated it, and what it represents. Now, just to make things clean, let's go ahead and add a legend to this chart. So we'll add a legend. And there are a number of ways we can do this. We could come right up here and just refer it to our envelope. And that would get the name right here. I'm going to Control Z to undo that and show you another way to do that is to select data, edit, and give it a series name by referring to the portfolio. Those do exactly the same thing. I get the portfolio word here because when I click on that, it's referring the first item in this series formula to that cell. So let's do the same thing over here. Let's click on this series. Notice that it's empty before the comma right now. We can refer that to the capital allocation line. Hit enter. We'll pick this up. And then let's do it with our portfolio. I think I chose portfolio when I should have chosen envelope. Envelope. Let's go back and change that. Move that portfolio up to the envelope. Say enter. And now I'll come back and actually choose the portfolio, which is what I want to fix. It's empty before the comma, but we're going to click on portfolio. So now it's looking for R11. To put a name here for series 3, hit enter, and it gives it the name portfolio. So we have our envelope, we have our capital allocation line, and we have this gray point, which is our portfolio. We didn't label our axes, so let's call one expected return, and let's call the other one risk. Let's name the chart as a risk return chart. If you have any questions, holler at me.